guys, welcome to another video, and today we're focusing on efficiency. Efficiency tells us how well an appliance can transfer energy usefully. Obviously, we want to use appliances that have a higher efficiency, which means there's less waste. Well, there's two ways that we can represent or show efficiency. And the first way is as a Sankey diagram. A Sankey diagram basically shows us the energy that's going in. And let's say that we have a light bulb and we have 100 joules of energy going into our light bulb. Well, these two arrows here show us the energy that's coming out. One would be useful, which would be light. And let's say that that is 80 joules of energy. Well, in your exam, you would be expected to calculate what is the output energy for this arrow. Well, we know from the conservation of energy that whatever energy goes into this light bulb, it also has to come out. So that would leave us with 20 joules of energy for this arrow. But what if we're asked to calculate efficiency? If you're asked to calculate efficiency, you could use this equation here, where useful energy, which is measured in joules, is divided by the total energy in joules. We then multiply it by 100, and that gives us our efficiency. Efficiency can be a percentage, or sometimes you could be asked to do it as a decimal place. Remember, the higher the efficiency rating, the less energy that is wasted with that appliance. Let's have a look at an example using this question here. And it says an object gains 60 joules of potential energy when it's raised by a motor. The motor was supplied with 200 joules of electrical energy. Calculate the efficiency. So basically, we've got a motor picking up an object. They've asked us to calculate efficiency. And I know that efficiency is the useful energy divided by the total energy times by 100. Well, the useful energy here is 60 joules because I wanted my motor to lift this object. And the total energy that was put into this motor was 200 joules. So we would do 60 divided by 200, which would give us an efficiency of 0.3 as a decimal place. We can times that number by 100. And that would give us the efficiency as a percentage, which is quite easily 30%. So this motor isn't very efficient at all because 70% of the energy is being wasted and only 30% is useful. At this point, it's important to know that no appliance will ever give us an efficiency above 100%. That's because we can't get more energy from an appliance than what we put into it. So if in your calculations you get efficiency that's above 100, you need to recheck your steps. Go to the website, guys, to have a look at some more examples of efficiency calculations. Now, because efficiency is very important to us, we want to figure out ways that we can make appliances more efficient. How can we make them so they waste less energy? Well, there's a number of different things that we could do. And the first thing is that we could lubricate the parts. By lubricating the parts, this reduces friction. The less friction there is in an appliance, then the less heat that's produced when the two surfaces rub together. We could also make objects more streamlined. When an object's more streamlined, there's less air resistance on the object, which means there's less heat energy being transferred to the surroundings. And we could also use appliances with little resistance. Appliances that have a high electrical resistance, they produce heat as a current flows through it. If we reduce that resistance, well then that means there's less heat produced as the current flows through. Okay guys, thanks for tuning in. Stay in touch for another video.